Hello, hi. My name is Dr. Tasveer Ahmed, and I am going to record this presentation for an interview. The topic I have selected for this presentation is CLIP, Contrastive Language Image Pre-training, which is a technique connecting the images and the text. Why I choose this topic for this presentation? Because I am currently working on this topic where we are adopting CLIP for the K-short training, K-short learning. Okay, next start the presentation. First we would talk about the history of the background and history of the clip model. So in artificial intelligence, there has been two streams. One is the imaging and video stream, and other pipeline of work was the natural language processing. So natural language processing in imaging and video processing, there are the large scale data sets has been compiled. For example, ImageNet, Mascoco data set, Pascal POC data set, and these were the image data sets, large scale image data sets, while the UCF 101, that was the large scale video dataset. Uh, that was one stream of work that was working on. The other stream of work was working on the natural language processing, where the datasets were, for example, glue language, general language understanding, and squad for question answering datasets. So NLP, it solved the problem and resulted in language modeling that solved the problem of text classification, machine translation, semantic understanding, and finally, natural language advancements in NLP processing that led to the large language models that we use currently in the case of GPT or the BERT. So these are the two main branches of the artificial intelligence. But there were the limitations of in the traditional computer vision or image processing. There were some limitations. For example, they're costly, and it was costly and to build a data set, and the data set was very narrow, specific to some to a specific task, and it requires millions of images to label, and there were limited number of classes. For example, a minute has only 1,000 classes, and expensive to create such data sets. And once the using those data sets, if we train a model is trained only for those specific classes. For example, like classification of cat and dog, it can't do anything else. So for new classes, we require new data, retraining, and custom architecture. So that was a big problem in the domain of computer vision. So then how CLIP it solves the traditional computer vision limitation. CLIP aims to address these problems by training a model on a wide variety of images, a wide variety of images and their natural language descriptions that are such images and descriptions are abundantly available on the internet. So by designing the network, by design such clip network, design can be leveraged to perform a great variety of classification benchmarks without optimizing the benchmark performance. So that led to the zero shot classification or zero shot learning. So the next was how this was the advantage of the clip. So digging down into the clip model is a language model that combines English language with a semantic English language concept with a semantic English language concepts with semantic knowledge of the images. So clip model is a neural network that is built on hundreds of millions of images and captions. It can return the best captions of an image, and it has an impressive zero shot capabilities that make it unique. So talking about the basic architecture of the clip. So clip learns by matching images with the corresponding labels, textual descriptions. In clip model, we have a image encoder and a text encoder. So image encoder encodes the computes the image embedding, encodes the images, and computes the embedding. Similarly, text encoder, it computes the text embedding for the textual descriptions, and then finds a similarity or mapping between them. So this is the main underlying principle of the CLIP model. So CLIP, once we get the trained CLIP model, that we can leverage it for the additional training or the zero-shot learning. Here in this case, we have a trained CLIP model, for example, a textual encoder, and when a query image come, its embedding is computed using image encoder, and this embedding is mapped or similarities computed for all the labels, and the best label is selected for this image in this case, which is dog in this case, a photo of a dog. So this is the underlying principle. Mapping or cosine similarity is the underlying principle for CLIP modeling. So CLIP is a cost efficient and flexible. In what sense? That it is costly to build a dataset in deep learning because it requires a lot of manually labeled datasets. It's time consuming and expensive. CLIP learns from text image pairs that are readily available on the internet and requires minimal labeling, and thus reducing the cost and the effort. CLIP also brings the flexibility beyond a single task or narrow models. Traditional models are limited for predefined classes, and for a new task, we require, as I told before, requires new data sets, retraining and fine-tuning. CLIP is flexible in the sense that it can be leveraged to many different visual tasks without extra training, and simply provide textual descriptions. CLIP also achieves comparable performance to the fully supervised model, so with minimal training. So CLIP image, so here I just brief about some of the data sets, some of the tasks that has been addressed using the CLIP model. For example, this is food 101 data set. There is the food classification using CLIP modeling. The sun is a scene understanding data set where CLIP model is used for the recognition of the television studio. This one is YouTube bounding box dataset, that is for object detection and object detection and tracking. Actually, also works fairly well for the detection of airplane in this image. And Eurostat is a land classification dataset in satellite imaging, and CLIP also performs fairly well for this dataset as well. So this is a depiction that CLIP model covers a wide variety of tasks, from recognition, scene understanding, to bounding box detection or object detection, to the satellite image recognition. So this is the generality of the CLIP model. So key takeaways of this discussion is that CLIP is highly efficient. It is trained or learned for more than 4 million publicly available image text pairs. It is 4 to 10 times faster than the traditional approaches, efficient than the traditional approaches. It uses the contrastive learning for optimal performance. CLIP is flexible and general because it can be leveraged for the zero-shot capability where no task-specific training is required. It works across diverse domains. For example, this is told in the last slide. For example, diverse domains. For example, OCR, geolocalization, finding, classification. CLIP performance is competitive with the supervised machine learning methods with a lot of training, a lot of GPU training resources are required, but those can be optimized with the zero or k-short CLIP modeling. There are some limitations associated with the CLIP modeling. For example, CLIP model requires reasoning is abstract. It's hard to explain to other than the computer science domain. Its explanation is really difficult. In the cross discipline, where the people have less familiarity with the machine learning or AI models. It's a performance. It's a for clip. The prompt sensitivity is high. If you slightly vary the prompt, then its performance and accuracy could be affected. So here are the resources which I searched through and read out for this presentation, for the slides, and you can simply go through them for further study. If you have any question, I am more than happy to answer. Thank you very much for this presentation.